Hello there. Today we'll be doing binary tree max path sum. In this particular problem, we are looking for the max path. This means that we are looking for a line through all of these nodes which has the maximum value. In example 2, where we have 9, 20, 15, and 7, the max path is actually 15, 20, and 7. This is the max path. As you can see, 15, 20, 7, you add those up, that's going to be 42. If you add any other path, which is a single divergent point of split, so from here to here, you're going to actually have less because of negative 10. Even though you have more numbers, it's actually less. Yeah. So a path can be a single number or more. A path could be 9, negative 10, 20, 7. Path could be 20. A path could be 15, 20. A path could be 15, 20, 7. So how we're going to do this is that we're going to take the middle item, and we're going to take the left max and the right max. So why the left max and the right max? Because we can only make one decision between at one particular point in a node, and we only take one path over the other path, and so we can only take the max path on the left side and take the max path on the right side. Suppose we take the path on negative 10, we can only take a path between 15, 20, and 10, or 7, 20, and negative 10. We can't choose both 15, 7, 20, and negative 10 and 9. We can only make that one split. So what happens is that we need to take either left max or right max at the particular point to push up to this particular point. So the left max and right max of 20 at this particular point, passing up to negative 10, is going to be 15, 20, 35, and then we're going to add negative 10 to that. That's going to be our max path on the right side, and the max left path is 9. So 9 and 35 for negative 10. So what is going to be our item is we're take the max. We're gonna take this item and add the left and right max path to get the I guess the longest pointer at this particular route. And we're gonna look at every single route into our max path. That's gonna be a DFS call. Anything else? Top down. We're going to go all the way down, get all those numbers, go all the way up. One thing is that if we have a negative number, like negative 7, we're going to just take that as a 0. We're just not going to take that item from our right side, and we're just going to take the left side instead. That way we have a higher quality item than 15, 20, and negative 7 versus a 20, and 20 and 15, which is higher. So yeah, that's what we're going to do. So with that, let's just code this out. So result is equal to, let's say it to root.val. Well, actually, I wonder what you would want to return if there was nothing. Let's set it to, can we set it to 0? Possibly. Let's set it to 0. So define DFS. We'll take our roots, take an optional tree node, and we're going to return an int. If not roots, then return 0. That's the base case at the bottom. Otherwise, what we're going to return is the left max between the left max plus the root.val, and the right max plus root.val. Right, so let's get the left max and right max and update the results as we move through. So non-local results is going to be equal to the max between the results and the left max plus the root.val plus the right max. So we need to get the right max and left max and shape that properly. So left max is going to be if I guess it's going to be the max between 0 and the DFS call of root.left, because it could be less than 0. So we're going to set that as our left max, and right max is going to be equal to a max of 0 or DFS of root.right, because this always returns this particular value, which is going to be, this particular value, which is root.val. Yes, with that, we can run DFS on the root and then return the result. Hopefully this works out. I'm not sure if it will work out or not, but we'll see. Okay, it did not work out because there's a single item called -3, and let's see. If we plug in the -3 into here, and we have left max, right max, they're going to be 0. So result equals the max of 0 and -3. It's going to take the negative. It's going to take the 0, and so the 0 is not going to work here. The node value is -1000 is the max, so we should set this as -1000. But I don't think that's going to work either. Let's suppose we set our test case to to nothing, and run the code. Oh, it's gonna work. It's gonna be at least 1. So we set it at -1000. So that's one way to set this. But if we do not want to set it here, if we want to be able to map out for all values, so if not root, then return what should we return? 0. And otherwise, result is equal to root.val. Wait, actually, we don't actually need this line because there's always going to be an item. So result's just going to be equal to root.val. Perfect. So I think this is as clean as it gets. The non-local part tells you that that's what we're setting. I like that. Better than using an array. Left max, right max, that tells you what we're going to get on the left side and the right side, and updating what we're going to do and sending what we're going to send back. So with that, I think that's a pretty good piece of code. If you enjoyed this video, like and subscribe. If you want more videos, check the link in the description below. Have any questions, comments, and I'll see you in the next one. Thank you. Bye.